Hi, this is Mr. T going through exemplar of how to answer the questions for Achievement Standard 91173 for 2015. How to demonstrate an understanding of electricity and magnetism. This is question 4. So 3 other videos on question 1, 2, and 3 you could go and look at, but in this video we're going through question 4. Okay, question 4 is all about a direct current. So you can see we've got a couple of circuit diagrams here. You should recognize the components here. We've got a battery, 9 volts. We've got 2 lamps with their specifics given up here. Okay, and we have a resistor. So let's have a look at the first question. Calculate the current. So I is what we want to find the answer to on each lamp that is operating at normal brightness. Now, normal brightness is what the brightness we would expect if it was operating at its voltage that's stated on it. Okay, so at its operating voltage, which is 6 volts. Okay, and if it's producing the wattage here, the power, that is 2 watts. So in order to find I, we're going to have to find an equation that has V and P in it, which is obviously the power equation. Because I want to find I, I'm going to take voltage and put it on the other side. It's multiplying on the right hand side, so when I put it on the other it becomes division. Substituting the 2 values, 2 watts on the top, 6 volts on the bottom, and we get an answer of 0.33 amps. So the current in each lamp is 0.33, which means here, okay, that bit there, going through that part of the circuit, we have 0.33 amps. Okay, which means that at the bottom as well, we're going to have 0.33 amps. Now, this is important when we look at the third question here. So this is an achieved question, straightforward equation, simple manipulation, and then a straightforward calculation. Just make sure you put down the units and the correct number of significant figures. So the second equation, we want to calculate the resistance of the resistor. Okay, so this is our resistor here. So I want to know the ohms of the resistor that he should use so the lamps are at their normal brightness. So when we're saying here that the lamps should be at their normal brightness, we're meaning that these lamps should use 6 volts. Now, using the loop law here, if these lamps are going to use 6 volts and we take one of these loops, then the resistor has to use 3 volts because 9 volts is produced, 6 volts is used by a lamp, then 3 volts is used by this resistor. Okay, so there's our voltage. The next thing that we can work out is if we want to find the resistance for this resistor, we want to know what its current is. Now, looking at what we did in the previous question, we knew that the current going through the lamps was 0.33 amps. And from our current law, we know that the current entering a junction is equal to the current leaving the junction. So in this case, we have the current going into this junction, and we have 0.33 going up and 0.33 going down. So in total, the current that traveled through this resistor is 0.66 amps. So now we know what the voltage and the current is going through that resistor. We can just use Ohm's law to calculate what our resistance is. And we get an answer of 4.5 ohms. So this is an in-depth understanding, We're using our voltage and a loop law, and we're using our current law to find the voltage and current across the resistor, and then from that Ohm's law to find the resistance. So 3 parts to it, but none of them are in their own complex, so that makes that a merit question. Okay, looking at question 3, what happens to the current with one of the resistors blow? And you can see, sorry, not one of the resistors, one of the lamps. You can see that our 2 lamps are in parallel. And what that means is that when the current goes and splits here, there is essentially two different choices for them to go through, or the resistance is decreased by putting it in parallel. So if I take one away, then actually the resistance is going to increase. When I make it not parallel, we get an increase in resistance. Now if I get an increase in resistance here, the total resistance of my circuit gets bigger. Now that's really important because the voltage, if the voltage stays constant and our resistance, okay, so let me just take Ohm's law and rearrange it here. So our resistance has increased, but our voltage stayed constant. We get this proportionality statement. So the current is inversely proportional to the resistance. So therefore, our resistance got bigger, our current is going to get smaller. So our current is going to decrease as the resistance is, 1 second here, increased. Okay, so you just make sure that you've got this bit here. So our resistance has increased. Okay, so that makes our current decrease. Yeah. Okay, so that's this question here is going to be show in-depth understanding again. So we've got a proportionality statement here. You've identified that it's gone from being parallel to being just one in series. So the resistance will increase. We've got a proportionality statement, and then been able to relate that proportionality statement to get the answer that the current will decrease. Let's have a look at the last question here. Calculate the voltage across a 2 ohm resistor. So this is actually, this calculation problem is a bit more involved than our previous one, and this is our excellence question, or excellence part to this question 4. So if I want to find the voltage across 4, then I'm going to need to know the current going through 4. And to know the current going through 4, I need to know the current that is coming out of this cell, this battery, sorry. The current coming out of that battery, because it's in series with 4, will be equal to the current going through 4. So if I find the total current of my circuit, I can find the current going through here. To find the total current of my circuit, I first have to find the total resistance. So, first step, find the total resistance. Finding the total resistance, I've got 3 resisting components here. First, I'm going to have to simplify these 2 here in parallel. Okay, so make them equivalent to, say, 1 resistance, and then I can add them to the resistance that's in series with them. So we're going to be using this equation here. This is for resistance in parallel, which has all of our resistance divided into 1. So we get 1 over RT equals 1 over 3 plus 1 over 6 gives us 1 over 2. And then in order to get RT, we're going to have to flip both sides of this equation over, or get the inverse of this. So RT equals 2 over 1 equals 2 ohms. One really important thing to note here is a lot of mistakes that I've seen in people doing these problems is they get this answer here. They forget that this is actually giving you 1 over RT, and to get the correct answer we actually have to flip or turn the whole equation over the other way. Okay? In essence, what you're doing is whatever the answer is to this, you're dividing it back into 1 again. Right, okay, so now we've got the total resistance. I just want to go through this again. So we had 1 over RT, okay, and that equaled to 0.5. Sometimes it's not going to be as a fraction, 0.5. To get the answer now, I have to divide 1 by 0.5, and that gave me the answer of 2. So yeah, it's pretty easy to do when we have a fraction because we just turn it over, but if we don't have a fraction, you have to remember that we're going to divide it into 1. Okay, so I know the resistance now, so the total resistance for the 2 in parallel is 2 ohms. That 2 ohms here is in series with the 4 ohms. So my actual total resistance is 6 ohms. So now I know the total resistance of the circuit, I can find what the total current is. Remember, I need the current to go through here to find out what the voltage is. So the total current using Ohm's law equals the total voltage, which is 9 volts, divided by the total resistance, gives us 1.5 amps. So now I know what the current is going out of my cell, out of my battery, and therefore I know what the current is going through here. It's equal to I total, right? And it equals 1.5 amps, so I can just use Ohm's law, and the voltage across here equals I times R, equals, well, that doesn't equal 9 volts. So look, we can look at the simple mistake I've made here is that I've put the total resistance, but I don't, if I'm just using the resistance for the resistor, I want to just use the resistance of the resistor, not the total resistance of the circuit, which is 4.0 ohms. So 4.0 ohms times 1.5 is going to give us 6 volts. Okay, so we're pretty happy with that. That makes sense. This is a different voltage than we had before, but that's because they have changed the circuit. Okay, so these use different lamps and a different resistor here, and we've got 6 volts, so we're pretty happy with that. Okay, look, if you found this useful, just share it with others, and look at the other videos I have going through the exam question.